Find the limit as x approaches infinity of this gross looking guy right here. We have x minus the square root of x squared minus 3x. If I were to plug in infinity, we would get infinities everywhere, and that's an issue. Can't do that. So this is what we can do. What I'm going to do is I'm going to go inside this square root and factor an x squared out of both of these. Now that seems weird, but give me a minute. Okay, this x hasn't been touched. The square root I'm about to mess with. If I factor an x squared out of both of them, I can factor an x squared out of an x squared, leaving me with 1. If I removed two x's from negative 3x, I'm left with minus 3 over x, right? Now what I can do is, since I'm now saying minus the square root of x squared times something, the square root of x squared kind of cancel each other out, and I can rip out an x. So you become x minus x, because the square root of x squared is x, and then times the square root of 1 minus 3 over x, like so. Okay, since there is an x in common in both of these guys, I can pull an x out of that, and I'm left with 1 minus the square root, 1 times the square root of 1 minus 3 over x. Now that I have 3 over x, I can apply the limit a little bit better. And this is going to be a little unique, but watch what I do. As I apply the limit as x approaches infinity, yes, x does become infinity, and that's weird, but wait. This becomes 1 minus the square root of, now whenever you have an infinity in the denominator, that whole thing becomes 0. So you, in a sense, will cancel out and leave me with the square root of 1, right? So now I have infinity times 1 minus the square root of 1. Well, the square root of 1 is just 1, like that. 1 minus 1 is 0. And even though you have infinity times 0, and that seems wrong, anything times 0 is going to be 0. So after all of that, the limit as x approaches infinity of this whole thing is going to be 0, because you end up with infinity times 0, and 0 is definitely going to beat infinity when multiplied to it.